I am Dr. R.M. Mastan Sharif, Assistant Professor in Mathematics, Department of Freshman Engineering, St. Martin's Engineering College. Now I am going to discuss the topic testing of hypothesis. Hypothesis is used to define the relationship between two variables. Testing of hypothesis is an educated guess to detect significance difference by sample statistics and population parameters. Sample statistics and population parameter. Next, the primary object of statistics analysis is used to data from a sample to make inference. So in this part, population size is Kaplan, the mean and variance of students in the entire country. The parameters are mu and sigma. Mu is a population mean, sigma is a population standard deviation, and sample population size is Kaplan. In that population Kaplan, we had selected small sample size, some small n. In that sample size, the mean and variance of sample size is a sample mean x bar and sample standard deviation s. Sample standard deviation s. Testing of hypothesis. What is the hypothesis? Many others have to define many definitions from time to time. In that part, the hypothesis is educated prediction that can be tested. Hypothesis is used to define the relationship between the variables. Relationship between the variables. Testing of hypothesis. Testing of hypothesis, we decide whether I accept or reject the hypothesis depends upon the population parameters or sample statistics. In that part, a test of statistical hypothesis is two decision problems after experimental sample value has been obtained, the action or acceptance of null hypothesis and acceptance of null hypothesis and rejection of null hypothesis. Next, statistical hypothesis is the statistical hypothesis parameters are using in that part population mean mu and population variance sigma square, population standard deviation sigma, population proportion p, and sample statistics x bar, sample statistic mean x bar, sigma s, etc. is there. In that part, next one is a null hypothesis. What is null hypothesis? Null hypothesis is denoted by H naught such that there is no significance difference between two values. What type of values means? There is no significant difference between sample statistics and population parameter. So reject the null hypothesis is directly we are using in that part is a acceptance or rejections. Acceptance or rejections. So example, suppose a doctor has to compare the disease in blood pressure when drug A and B are using. So therefore, H naught such that mu A is equal to mu B. Next, alternative hypothesis. Alternative hypothesis is denoted by H1. Alternative hypothesis denoted by H1. The alternative hypothesis always against of the null hypothesis. This is a H1 such that there is a significance difference between population parameters and sample statistics. So the symbol of the alternative hypothesis is not equal to or less than or greater than. Not equal or greater than. Example, H naught such that mu is equal to mu naught, null hypothesis. Alternative hypothesis, H1 such that mu less than mu naught or H1 such that mu greater than mu naught is a alternative hypothesis. One side alternative hypothesis and two side alternative hypothesis. Null hypothesis H naught such that mu is equal to mu naught. H1 such that mu is not equal to mu naught is a two side alternative hypothesis. Next one, critical region. According to this diagram, we have two parts are there, acceptance region and critical region. What is the acceptance region or critical region? Both are not the same. So the critical region is a rejection region. In that part, acceptance region is a 95% confidence in this diagram, and rejection region is a alpha percent, or alpha means is a two sides test, alpha by 2. So this is that. Next one, level of significance. Level of significance alpha is denoted by alpha. This is a probability of type 1 error. We will choose alpha, we will choose alpha either 1% or 5%, either 1% or 5% or 10%. Next, two-tail test. Tail tests are three. One is a two-tail test, next is a right-tail test, another is a left-tail test. Next, two-tail test. The alternative hypothesis contain the not equal symbol. The hypothesis is two-tail test. The two-tail test has the area of P is equal to of the P. This is the diagram. In this diagram, this is a critical region, alpha by 2, alpha by 2. Alpha by 2, P is the twice the area to the left of the negative, and P is the twice area right of the negative. Next, right tail test. The alternative hypothesis contains greater than symbol. The greater than symbol is called right tail test. In this diagram, in this probability diagram, a critical area is a right side. So, because null hypothesis H0 such that mu is equal to k, alternative hypothesis H1 such that mu greater than k, this is the right side of the area, right side of the test statistics. Next one, left tail test. Left tail test, the alternative hypothesis contain the less than inequality. The hypothesis called left tail test. So H0 such that mu is equal to k, H1 such that mu less than k, means in this probability diagram, in this normal distribution diagram, left side is a critical value. It's the area is to the left of the test statistics. Next, type 1 error. Type 1 error is when null hypothesis is rejected, when it is true, that is called type 1 error. Type 1 error, the probability of type 1 error is denoted by alpha. Now, type 2 error, accept the null hypothesis. When null hypothesis is false, that is called type 2 error. So, type 2 error, probability of type 2 error is denoted by beta. Beta is the symbol of type 2 error. Next one, there are maybe four possible situations in this table. One is decision. Decision is acceptance of null hypothesis H0. Another, rejection of null hypothesis H0. Next one, actual truth of H0. H0 is true, H0 is false. So reject the null hypothesis. When a null hypothesis is correct, that is called type 1 error. Accept the null hypothesis. When null hypothesis is false, that is a correction. Accept the null hypothesis. When null hypothesis false is a type 2 error. Accept the null hypothesis correct is a correction process. Next one, procedure of testing of hypothesis. Mainly procedure of testing of hypothesis, we have 5 steps. One is null hypothesis and a H0, and alternative hypothesis H1, level of significance alpha, test statistics T, or F or chi, conclusion. So next one is a test statistics is a formula. Test statistics we will use test statistics Z test or F test, etc. is there. So test statistics is a test statistics is now I am going to explain Z statistics, and this is the Z statistics. So in the Z statistics, in Z test, we have Z test, 4 methods are there. One is test for single mean, second one is test for 2 means, third one is test for single proportion, fourth one is test for 2 proportions. First one, test for single mean. Problem, let we take n is equal to 64, x bar is equal to 70, mu is equal to 56, and sigma is equal to 25. So this data available, sample size n is equal to 64, and sample mean x bar is equal to 70, and population mean mu is equal to 56, and population standard deviation is sigma is equal to 25. In this data, we can fit in test for single mean. According to the procedure of test for single mean, first one is a null hypothesis. First one is a null hypothesis. Null hypothesis is generated by H naught. Null hypothesis generated by H naught. H naught means there is no significant difference between two population means or two sample means. So H naught such that mu is equal to 56. So there is no significant difference between sample mean and population mean. Step number 2 is a alternative hypothesis. Step number 2 is a alternative hypothesis. The alternative hypothesis H1 such that alternative hypothesis H1 such that mu is greater than 56 because of regarding the problem. In this problem, it's a one-tailed test. So there is a significant difference between sample mean and population mean because alternative hypothesis against of the null hypothesis. Always null hypothesis and alternative hypothesis both are not, at the same time not accepted, both are at the same time not rejected. One should be accepted, other should be rejected. Next one, third step is a level of significance. Level of significance alpha. Level of significance alpha. Choose approximate level of significance alpha at 5% or 1% or z%. If any percentage is not available, we will go for 5%. In this problem, in the given data, sample size n is equal to 64. It's a large sample because it fit for Z test for single mean. And sample mean x bar is equal to 70. So in population mu is equal to 56. Population standard deviation sigma is equal to 25. In this problem, we will go for Z test. Z test has some fixed table values. If Z table value at 5% level of significance is two-tailed test is 1.96. Same thing, Z table value 1% level of significance at two-tailed test is 2.58. Z table value 10% level of significance with two-tailed test is 1.645. In the according to this, I am writing Z table value at 5% level of significance, with one-tailed test is equal to 1.645. So this is the step number 3. In the procedure of test statistics, we have 5 steps. In the 5 steps, first step is a null hypothesis. So second step is a alternative hypothesis. Third step is the level of significance alpha. According to the given data, sample size is a large sample. That's why we go for some test for single mean. In the single mean formula, we go for next step. Next step is a step number 4, test statistics. Step number 4, test statistics. Before Z is equal to x bar minus mu by sigma by root n. Sigma by root n follows n of 0, 1. So this is a test for single mean formula. Z is equal to mod of x bar minus mu by sigma by root n. X bar is a sample mean, mu is a population mean, sigma is a population standard deviation, n is a sample size, it's a large sample. Follows normal distribution, mean 0, variance 1. So that's why we have substitute these values in this part. Z is equal to 70 minus 56 by sigma 25 by root 64. This is a formula. Z calculated value is equal to approximately 4.48. This is the fourth step. The 4.48. This is the fourth step. So what is the fifth step? Fifth step is a very important test. This is a decision criteria. According to this test, we have to decide null hypothesis is accepted or rejected. If accepted means what situation it is accepted, rejection means what situation it is rejected. This is called the conclusion or decision criteria. Compare the null hypothesis, alternative hypothesis, and using level of significance alpha, then we have to decide what is the conclusion is accepted or rejected. Next one, fifth point is a conclusion. In this conclusion, from the above means null hypothesis, alternative hypothesis, level of significance, we have to utilize this test. Is a what is the Z calculated value? Z calculated value is 4.48. So compared to level of significance alpha, level of significance alpha step number 3 is a 1.96. So compare this to compared to this two, level of significance is 1.96 and that is called Z table value, and Z calculated value is 4.48. So from the above, the calculated value of Z is 4.48 is less than to the table value of Z, table value of Z at 5% level of significance, at 5% level of significance with one tile test is 1.645. 1.645. In this comparison is less than, that's why we reject the null hypothesis. We reject the null hypothesis, that hence we conclude that there is no significance difference between sample mean and population mean. Next one, we go for second. Next one, second test is a test number 2 is a test number 2. This is test for two population. Test for two population. Test for two population is in large sample. In large sample. In this large sample, we are using the problem says n is equal to problem is so given problem, given data, n1 is equal to 1000, n2 is equal to 2000, x bar is equal to 67.5, y bar is equal to 68, sigma is equal to 2.5. This data is fit for only test for two population means. According to the test for two population mean, also for the same procedure, testing of hypothesis procedure. First step is null hypothesis, second one is alternative hypothesis, third one is level of significance, fourth one is test statistics, fifth one is conclusion or decision criteria. But some difference is there. But some difference is there in the according to the difference. What is this? That this has at a time we are taking two samples. That is a sample 1, N1. That is sample 2. Both samples according to this are large. These both are large samples. They both are large sample. That's why we go for Z test. In this test, step number 1 is a null hypothesis. Step number 1 is a null hypothesis. So H0 such that, what is the null hypothesis? H0 such that there is no significance difference between in two sample means. In the first sample mean is a 64, 67.5 etc. is there, and y is equal to 68. There is no significant difference between H0 such that mu1 is equal to mu2. Mu1 is equal to mu2 means first mean is equal to population mean is equal to second population mean, both are equal. Second one is a alternative hypothesis. Second one is a alternative hypothesis. This alternative hypothesis is always against of the null hypothesis. According to the formula, alternative hypothesis is complementary to the null hypothesis. So there is a significance difference between two means. First case, null hypothesis is a no difference. Alternative hypothesis is a difference. H1 such that mu1 is not equal to mu2. Mu1 is not equal to means is a two-tile test. It's a two-tile test. It's a two-tile. So because of this is a complementary. In these two steps, first step is null hypothesis. Second one is test is alternative hypothesis. Both are at a time not accepted. Both are at a time not rejected in each and problem. Each and every problem, if we have to accept the null hypothesis, we should reject the alternative hypothesis. We reject the accept the alternative hypothesis, we go for null hypothesis. Step number 3, level of significance. Level of significance alpha. Level of significance alpha. So this is a alpha. Probability of type 1 error is called the alpha. The alpha is a level of significance. Choose approximate level of significance alpha percent. But alpha percent is either 5% or 1% or 10%. But according to this problem, the level of significance, percentage, critical value or confidence interval is not available. If not available, we go for 5%. That's why Z table value at 5% level of significance, at 5% level of significance with two-tile test is equal to 1.96. This is a fixed value because of Z values are fixed values. So level of significance Z is equal to 1.96. The next step number 4. Next step number 4 is a test statistics. So test statistics. In this test statistics, we have to use the formula Z is equal to x bar minus y bar by sigma of 1 by n1 plus 1 by n2. Sigma of 1 by n1 plus 1 by n2 follows n of mean 0, variance 1. So what is Z? Z is a large sample. So x bar is a first sample mean and y bar is a second sample mean. Y bar is a second sample mean. So in this part we have to obtain what is the difference between x bar and y bar. So according to the given data, Z is equal to x bar is a 67.5, y bar is equal to 68 by sigma 2.5 is root of 1 by n1 plus 1 by n2. Z is equal, Z calculated value is equal to 5.16 approximately. 5.16 approximately. According to this compared to step number 1, null hypothesis, step number 2, alternative hypothesis, level of significance, in this Z calculated value. In this 4, Z calculated value is 5.16, but level of significance alpha is a Z table value, yet 5% level of significance is 1.96. In this comparison, we have to take the decision criteria, that is called the step number 5 is a conclusion. Step number 5 is a conclusion. In this conclusion, we have to compare the step number 3 and step number 4. From the above data, Z calculated value is 5.16 less than greater than to the Z table value yet 5% level of significance, with two-tile test is 1.96. In comparison is always greater than means we reject the null hypothesis, means there is some significance difference between two values. There is some significant difference between the two values. Next one, we go for this value. This is a video. This is a video according to this null hypothesis. Testing of hypothesis is the process of testing of hypothesis process of the hypothesis. Hypothesis is used to define the relationship between two variables. Hypotheses are two types. One is null hypothesis, second one is the alternative hypothesis. Null hypothesis is the H0 such that there is no significance difference between two means. H0 such that there is two means. So in that part, test statistics is a significance difference referred as status quo, always is equal to sign. That's why in this part, null hypothesis is a acceptance or rejection. We have to decide if it is acceptance or rejection depend upon the problem. Next one is the alternative hypothesis. Alternative hypothesis denoted by H1. And is a always against of the null hypothesis, challenge the status quo. So it is not equal to sign H1 such that H1 such that mu1 is not equal to mu2. Not equal to means it's a two-tile, either less than or greater than. Sometime alternative hypotheses are two sides. One side alternative hypothesis, two side alternative hypothesis. This is a two side alternative hypothesis. For example, we are taking tossing of a coin. Tossing of a coin is a classical probability. In this probability, P is equal to always half. P is equal to always half. In this probability, head and tail, tossing of a coin has only a head and tail. In this head and tail is a equal preference. P is equal to half, Q is equal to half. According to the classical probability, P is equal to 0.5. It is fit for null hypothesis. But alternative hypothesis always against of the alternative hypothesis. So that's why this alternative hypothesis is H naught such that P is not equal to 0.5. Next one is a type 1 error and type 2 error. Type 1 error is a reject the null hypothesis. Rejection of null hypothesis when null hypothesis is true is called type 1 error, and it is generated by alpha. And accept the null hypothesis when null hypothesis false is called type 2 error. This is generated by beta. So this is a one animation where Dick and Ruth, where Dick, one innocent person, so innocent person is in jailed. Innocent person is jailed means reject he is innocent, he is a good, but he is in jail. This is called type 1 error. This is called the type 1 error. And if he is a innocent person, he is set free, he is free. This is a correct decision. This is a correct decision. Second, if set free jailed person is in jail, who is a guilty person in jail, that is a correct decision. And who is the set free person is a free, that is a type 2 error. That is a type 2 error. So type 2 error means, so we accept the null hypothesis when it is a false, means that is a type 2 error. Type 2 error is generated by beta. Type 2 error is generated by beta. So according to this, type 1 error and type 2 error is there. So according to this formula, this is type 1 error and type 2 error. Another example is there. So another example is there. That says, next conclusion, according to the testing of hypothesis, we have null hypothesis, testing of hypothesis, null hypothesis, alternative hypothesis, level of significance. Next one, critical region, type 1 error, type 2 error, and one tail test, two tail test, etc. One tail test and two tail test, etc. is there. According to utilizing this methods, we have to test the any statistical data. It is good or not. Same thing we go for small sample, because testing of hypothesis are two cases. Testing of hypothesis 1, testing of hypothesis 2. Testing of hypothesis 2 is a small sample. So in testing of hypothesis sample size n less than or equal to 29, we have to go. We can solve with the help of the t-test or f-test and chi-square test. T-test or f-test and chi-square test is a fix for small sample. What is the t-test? What is f-test? What is chi-square test? T-test is a test for single mean. It's like a Z test. So, but sample size is small. T is equal x bar minus mu by s by root n follows t n minus 1 degrees of freedom is a t-test. Next, f-test is a test for whether the two population variances are difference or not. That is a f-test. F-test is equal to variance of s1 square by s2 square. So sometime s1 by s2 should be greater than 1 if it is good, if not we less than 1, or we replace the f of is equal to s2 square by s1 square. So the same again, next chi-square test. Chi-square test is equal to, chi-square is equal to double summation of oij minus eij whole square by eij follows chi-square n minus 1 into r minus 1 degrees of freedom, n minus 1 into r square degrees of freedom. In this process, we can get some calculated value. Compare these t-test, f-test, chi-square test t-value, chi-square table values. It's not a fixed values. We have to utilize the t-sheets or f-sheets and f-table values and t-table values and z-table values. Depends upon the sample size. Each and every problem has different types of sample size. A level of significance are there. That's why you have to utilize the statistical table. Next one, conclusion. So in this problem, in this method, we have to utilize, we can fit for all the problems in the testing of hypothesis. That's why we can use either Z test or T test or F test or chi-square test. All are testing of hypothesis, but sample size depends upon the sample size. It may be Z test or T test or F test or chi-square test. So it depends upon this. We can give the conclusion. Conclusion with the help of the T table, F table, Z table, etc. That's why we are giving to the problem. We have to solve this problem with the very level subject problem. So everybody should solve this problem. We can utilize the F test, Z test, and T test, etc. So it is very useful for us, etc. That's why. So in that part, we are going to conclude that I'm going to give the conclude that there is a significance or non-significance is depends upon the problem. Okay. Thank you for all.